You may have seen some of my other videos, but this is completely different. This is for proof with segment additions. Here's the example we're going to use. Okay, the given is PQ equals RS. PQ is right there and RS is right there. Okay, and that's clearly the given. Okay, if we're trying to prove that PR equals QS, then we'll need to use these steps. First off, it's PQ plus QR. PQ plus QR equals QR plus RS. QR plus RS, because they're both the same, and that is called the addition property. Step number 3 is PQ plus QR equals PR. PQ plus QR equals PR because of segment addition postulate, which states that, like for instance, in this case, Q is in between P and R, and we add PQ and QR. Then, since we're adding those two and those two, that entire line would be PR. And then QR plus RS equals QS for the same reason. Okay, and then the last step, we just substitute that, just add these two into the equation right there because of substitution. Okay, proof of segment congruency. Okay, our givens is JK is congruent to KL, JK is congruent to KL, HJ is congruent to GH, HJ is congruent to GH, and KL is congruent to HJ. Okay, that was the given. Second step, JK is congruent to HJ, JK is congruent to HJ, and JK is congruent to GH. And that was the transitive property. And finally, GH is congruent to JK through the symmetric property. Okay, supplementary angles. Angle 1 and angle 2 form a linear pair, and the measure of angle 2 is 67. Find the measure of angle 1. And the measure of angle 1 is plus the measure of angle 2 equals 180 because of the supplementary, which states that if two angles form a linear pair, then they equal 180, or they are congruent. And then next step is angle 1 plus 67 equals 180, which is basically the measure of angle 2 equals 67. Okay, and then you want to subtract 67 from 180 to find the measure of angle 1, which is the subtraction property. Okay, we are given that angle A equals angle B. We need to prove angle B equals angle A. Okay, first off, that's our given, right? Okay, so by the definition of congruent angles, the measure of angle A equals the measure of angle B. And I know my handwriting sucks, just pointing that out right now. Okay, using the symmetric property, which is switching these two around, we can point out that the measure of angle B equals the measure of angle A. Okay, use of supplementary angles. Angle 1 and angle 2 form linear pairs, and angle 2 and 3 form linear pairs. That is our given, as you can see. Okay, step number 2. Angle 1 and angle 2 are supplementary angles. angle 1 and angle 2. And also angle 2 and angle 3 are supplementary angles, angle 2 and angle 3. Which, in conclusion, angle 1 is congruent to angle 3 because they are supplementary angles, which are the same angles, or the angles are congruent to each other. Okay, the way I remember this particular theorem, which is perpendicular lines intersect to form right angles, is I think of a crossroads like in Fort Dodge or any other town you can think of that have like a 4-lane intersect. Like for instance, here's 2 and here's 2. Since they cross paths and these form right angles, right? As you can tell by the little boxes I've had my assistant draw. Well, anyways, this is one reason why I remember this one so clearly, because of the intersection.